06180, I'm going to present the introductory part of our project. There is no country which has no traffic signals, and still they all are facing problems with traffic system, and this problem has now become so much complex to overcome within our country. In this regard, we choose to help the system to implement our project four-way smart traffic control system with pedestrian movement. Here in this project, in the right sided view, we can see that the layout of the road has symmetrical top view with a roundabout at the junction of our four roads. All roads are divided by road divider island, and each side of the roads has dual lanes. In this project, we use PWM generator, ring counters, and logic gates to implement our smart traffic system of four-way, four-lane road along with pedestrian crossing. In this scheme, transport passing and pedestrian crossing both have been implemented without completely stopping all the roads for a single second, and it was ensured that the rush of the passing transport of cars can be minimized efficiently. Thank you.
System notation: roads. Four roads have been marked A, B, C, D. Pedestrian path. If anyone stand on road A island facing towards the roundabout, then the path from his standing island to his right-hand side footpath of road A is marked as pedestrian path IA. The path from his standing island to his left side footpath of road A is marked as pedestrian path IA bar. Similar definition is taken for pedestrian path IB, IB bar, IC, IB bar, ID, ID bar.
Let's talk about the system functions. Here we can see the part A portion of our four-way route. The green light here indicates that the vehicles moving from road A to road BCD. During this time, outgoing from road BCD remain off. Here, if we look at the pedestrian path of road A, we can see the light of the IA part is green, but for the IA prime is red. That means IA is available for the pedestrian to cross, but IA isn't, as there is no incoming vehicle in the IA part of road A, but transports are moving in IA prime. After some moments, the yellow light glows, which give a signal for the outgoing transport of road A that they have to stop in any moment and wait. In the same moment, the yellow light of road B will glow, which gives the signal for the outgoing transport of road B that they will start soon. Both the pedestrian path IA and IA prime will show red signal. That means no zebra crossing is acceptable in both sides. Next, here we can see from the signals, the outgoing transport of road A are stopped from the next three triggers of the cycle, and simultaneously the outgoing vehicles of road B starts moving. As a result, the IA part of pedestrian path has red signal, so no crossing will happen here, but IA prime is free to cross for the pedestrian.
In this slide, I'm explaining the most important and crucial part of our project. Here in the logic table, the triggers mean basically three different phases of operation for a certain road. If the total cycle operates for 144 seconds, then each of the road will be triggered for 144 by 4 is equal to 36 seconds nearly. Each of the roads have 3 phases of operation, and so there are total 12 phases. The 12 phases of the signals have been generated in a 4x3 basis using two 4017 ticket counter IC and 7408 IC. It will be explained later. One point is the first 8 outputs of the counter IC are combined using OR gates to achieve the duty cycles of 0 to 62.5%, 62.5% to 87.5%, and 87.5% to 100%. As we used for test outputs of the ring counter, we have one road triggered for 4.5 into 8 is equal to 36 seconds. Here 4.5 is the period of the PWM signal generated from the 555 primer. Now we will analyze the signal of road A. In 36 seconds, signal PA1 stays for 22.5 seconds, signal PA2 stays for next 9 seconds, and the signal PA3 stays for next 4.5 seconds. The other road signals are similar to this. In previous slides, road function have been described. Keeping that in mind, we will analyze road A here. Road A is open for outgoing cars for first 87.5% time of first trigger. Then the yellow light will appear for road A cars to stop and the road B cars to start. After that, the road A is off for the rest of the time. Similar logic is true for road B, but for the second set of the trigger. Road C for the third set of trigger, and road D for the last set of trigger. Now we may analyze pedestrian movement. When road A is green signal, pedestrian path IA is free, and before road A being yellow, the pedestrian path IA is signaled by yellow for safety of the pedestrians. The rest sets of the signal is red for this path. Conversely, when road A is free for the cars, path IA prime is strictly off for the pedestrian and signal red. And when road A is outgoing is off, path IA prime is free for the pedestrians. This is all about road A. So in the first figure, the column operation can implement the signals of road A. So this is shown in the table. For example, in road A, the red signal is generated by the OR output from PB1, PB2, PB3, PC1, PC2, PC3, PD1, and PD2. So 8 signals are OR gated, and output is named as A road red. For yellow signal, this is PD3 or PA3. And for green signal, this is named as PA1 or PA2. So like this, all other signals are generated. And now we will explain the pedestrian path IA. This is A road red or A road yellow. So first 8 signals of road A and 2 signals of two yellow signals for road A. All signals are OR gated. For pedestrian path IA yellow signal, this is PA2, and pedestrian path green signal, this is PA1. For pedestrian path IA prime, this is PA1 or PA2 or PA3. For pedestrian path yellow signal, this is PD3, and pedestrian path IA prime green signal, this is A road red. Similar to the signal we have analyzed for road A, red. Now we will go in the next slide. This slide, I'm explaining the operation of 555 timer. The period is adjusted to 4.5 seconds in the hardware, and evaluating the formula of the frequency, we calculate the period is 4.44 seconds, but the actual hardware, we get the period is 4.5 seconds. But we adjusted the values of the parameters in the software in such a way that the runtime of the entire simulation is smaller than that in hardware. Now we will explain the function of the ring counter IC4017. Ring counter shifts the input pulses from output Q0 to successive outputs with just a completion of a period of the PWM, and resets at pin with which the reset pin 15 is connected to. This is why the duty cycle is not important here. In other sense, pin 14 takes the positive edge of the clock as trigger. In the first figure or counter U1, the upper ring counter is used for activating roads A from its output Q0, road B from its output Q1, road C from output Q2, and road D from output Q3. And in the lower counter, U2 is used for each trigger from Q0 to Q7, and Q8 pin is connected to pin 15 for reset.
Performance and limitation. The traffic system is defined by the percentage running time of transport and the percentage time of pedestrian road crossing. In terms of above parameters, system performance can be evaluated from the logic table. The transport of any road runs in total 21.875%, and the pedestrian have the best and worst efficiency that can be calculated. Best efficiency arises when the pedestrian comes from a road IA, stops for a small time, and then crosses the IA bar. They have to wait only 13.5 seconds, and the efficiency will be 90.625%. Worst efficiency arises when a pedestrian comes from road IA bar as soon as the green light is on, stops for a long time, and then crosses the IA. So they have to wait 1 minute and 16.5 seconds. So the running efficiency will be 46.875%.
We will see what we have done for the software simulation part. In your screen, you can see the Proteus simulation snippet of our project, which will be further discussed in the upcoming videos. Let's wait for a minute. And then we will see the hardware demonstration of our project, the main part of all of it. Here in the screen, the 3 pictures represent our hardware simulation demonstration of our project, which will be discussed in the further video. And with that, our presentation comes to an end. Thank you. That will be all. Assalamu alaikum. This is 1706-175 Farhan Hamid here to demonstrate our simulation file of this project. In your screen, you can see that the PWM here has generated our signal for the period. This LED white is showing our period for the entire signal. Afterwards, as mentioned in our presentation slides, we have used 2 decay counters, and the decay counters have been used to create the periods of 0 to 62.5%, 62 to 87.5%, and 87.5 to 100%. All these signals, and along with for the 4 rows, we have also created the 4 signal parameters of 0 to 25%, 25 to 50%, 50 to 75%, and 75 to 100%. Here for the simulation file, we have also attached some LEDs to see if our signals actually work. After that, according to our logic diagram, we have implemented all of the logics using basic gates. Here we can see that in the signal trigger of PA1, PA2, PA3, along with for the B, C, D cases, for each of the trigger pins, we have implemented the roads of PA1, PA2, PA3, PB1, PB2, PB3, PC1, PC2, PC3, PT1, PT2, P33. Here we have AND gated the 0 to 62.5 and the period for the roads lightning according to for each of the roads for A, B, C, D. And afterwards, according to the logic, we have also implemented the rest of the circuit logics using the basic gates. And here, after we get the list of the basic gates, we can see our output for our project. Here for our output project, we will see that the traffic light system shown here is correspondingly to our hardware simulation. If we take this road as road A as said, here when the road is having a green signal, which means IA prime is having cars coming out of it, and thus it is having a red signal for pedestrians not to cross it. And we see a yellow light here, which means in any moment we'll see a change in road A. Here now we see road A is having a red signal. Thus, there is no car coming out of road A. Thus, we have a green signal in the IA prime, which means pedestrians can cross these streets. But this also simultaneously means that cars from other roads can come and go through this road, and thus pedestrians cannot walk this lane, and thus we have a red signal in IA right. This logic, which has been said here, works in all the same manner in road B, in road C, in road D. And this is our entire project simulation file, and which will be further demonstrated in our hardware circuit. Thank you.
Assalamu alaikum. This is 1706-175 here to demonstrate our hardware project implementation. As previously said, we have used a 555 timer IC here to generate the main period of our entire project. Afterwards, it has been fed to two ring counters here. The ring count among the two ring counters, one ring counter has been used to produce for 25% of time periods, which will be given to all four of the roads, road A, road B, road C, and road D. And the another ring counter has been used to produce some periods in the range of 0 to 62.5%, afterwards to 87.5%, and afterwards to 100%. Afterwards, all of these signals have been fed to some universal gates. These basic gates have been used to implement all of those periods which will hence be used in our traffic control system, which has been previously presented in our software simulations. All of the basic gate simulation can be seen in the middle three breadboards, and in the initial breadboard here we have implemented the 555 timer IC along with the 24017 ring counters. Afterwards, if we notice in this portion of our project, we have implemented the traffic control light system along with the pedestrian movement. If we focus here that all of these roads are simultaneously connected, this road which comes from here is said to be A, this is B, this is C, this is D. The black tape in this project hence shows us the definition of the roads, and the white tape here in the middle is giving us the border, so that when we see that the three LEDs connected in this road, we will understand that this road is being used as the outcoming road of road A. And similarly, the three LEDs here connected in this portion will give us the idea of these three LEDs connected as the outcoming road of road B, simultaneously road C, simultaneously road D. Again, as previously said in our logic, the IA prime of the LEDs have been connected with this traffic module, and the IA traffic module for the road A has been connected in this traffic module. These traffic modules are connected in all four of the roads. Thus, we see two more, a total of 8 traffic modules to demonstrate the pedestrian movements. Here, the red tapes indicate the position of the traffic modules which are used to enhance the pedestrian movement, the black for the roads, the white for dividing the roads, and also the white tape which has been used to given in the middle bridge shows us so that the pedestrian's movement can be calculated. Here, when we go for the run, we will see that for any individual light of road A, when the cars are not moving coming out of road A, we will see the green light here will glow, and thus indicating that IA prime people in IA prime should cross the street, and thus when this outcoming road of road A is closed, thus the incoming cars of road A will be hefty and will be moving, and thus IA will give a red signal showing that you should not cross the road. All this logic will be shown simultaneously in all of these projects. So in the next part, we will connect the battery and see how this demonstrates. Start. Here we can see that road B is having a green signal, thus indicates cars are coming out of road B and going to road C, road D and road A. And due to the fact that road B outcoming is having green, the AIB prime road has a red signal, which means pedestrian should not cross here, and this is having a green light signal, which means pedestrian should cross here. Now it is blinking yellow, thus we mean that in any moment this signal will have a shift of colors. Since IB is having a yellow, that now we have a yellow here and a yellow there, thus road C will eminently have color C signal and road B is now red. And simultaneously, since road C has a green signal, the IC prime is now having a red signal, means pedestrians shouldn't cross this half of the road and pedestrians can cross this latter half of the road, and thus we are having a green signal over here. This is how the road C is here operating. In all of the traffic control system or of this four-way system, eventually this is a symmetrical one, and eventually after the road C operates the exactly same manner, we will see that road D is conducting. Right now road D is having a yellow light and now it just turned to green light. The green signal means the road D outcoming cars are coming out, and thus pedestrians in the ID side can cross, thus it is having a green signal, and the pedestrians in the ID prime cannot cross, thus it is having a red signal. This is the same procedure how road D, road A, road B, road C are working, and now seeing it having a yellow signal in ID, it means in any moment road D and road A will have a green, just like now we are having a yellow signal, and the yellow signal will later on prove that road D has hence got the red signal and road A is again into its green signal. With road A's green signal, we see IA prime is now closed, thus having a red signal, and with that the IA side is having a green signal, which means pedestrian can cross this half of the system and pedestrians should not cross this up, as we are having a traffic here. So with all this entire circle, we get a total of 144 seconds due to our arrangement, and finally we are again come back to our previously initial point of road B having the green signal. With this, our hardware demonstration comes to an end, and this is how our four-way smart traffic control system, all of these four ways and along with the pedestrian movements, each two in each road for all of the half road movements have been implemented for our EEE304 project. Thank you.